Alright, so this is the memo for the Term 2 weekly practice worksheets, week number 1. So the first question we have there is to write out the name of the organization that's responsible for collecting tax in South Africa. So the abbreviation is SARS, right? But they want you to write out the full name, so you would need to say South African Revenue Services. The second question asks you to explain what a tax threshold amount refers to, and that is on your table over there. And the tax threshold amount is the minimum you must earn to be eligible to pay tax. You could also say it's the maximum you can earn before you start paying tax. So it's got to do with the limit after which you can start to pay tax. The next question asks us to calculate Mrs. Seko's annual taxable income. So let me go on to a new page for that. Okay, so we have here Mrs. Seko, 58 years old. She has a gross salary of 46,000 Rand per month. And they also tell us that she contributes 7.5% of her gross salary towards her pension fund. And she pays 1,600 towards a charity. So those are the three things. They tell us there that both of these contributions are non-taxable. So they're literally telling us you need to take it off before you calculate your tax. So let's calculate them. We start with our 46,523.16. We need to take away the 7.5%, and remember we always go 7.5% of a number, so it would be 7.5% of his salary, so of the 46,523.16. And we also need to take away the 1,600 for charity. Then we can calculate that out. You get 46,523.16. Take away the 7.5%, which is 348,9.24, and then we're also going to take off the the charity. There we go. And when you calculate that, you get to 41,433.92, and that is per month. And they wanted it per annum because that was for annual taxable income. So all we do is take our answer, 433.92, and we'd multiply it by 12, and you're going to get to 497,207.4. And because it's money, we need to put our rand symbol. Apologies, it should be .04. So get that there. And that is our final answer. Now, when I marked a few learners with this section, what a few people did is, rather than doing this first subtraction and then multiplying by 12, and quite a number of people who multiplied by 12 first. So they did the 46,000 and they said, let's take this times by 12, and then let's take this times by 12, and then this you obviously don't need to, because you would just be going 7.5% of the annual amount. That's also perfectly fine to do it in that order. The only thing to remember is, if you are multiplying by 12 first, this charity amount must be multiplied by 12. You can't just subtract the 1,600 from the annual figures. So I would generally suggest, if most of the numbers and most of the information you're given is per month, rather subtract monthly, then multiply by 12, just so that you don't forget that step. Alright, question 5.1.4, we've got here about Mrs. Seko's friend who earns an annual taxable income of 502,000 Rand per year. She claims that she pays more than a quarter of her annual taxable income towards tax each year, and they want us to verify whether the statement is valid. So the first thing that we're going to need to find out is we need to know, well, what was her tax that she pays each year? Because if we know what the tax was, we can then see, is it a quarter of her salary? So to do that, we're going to need to look at our tax tables, and we're going to see that for her, we can see that for her she's got 502,000, which means that she will be falling into this bracket over here. So let's just calculate. They already give us that it's taxable income, so we don't need to take off pension or anything like that. So we can just start with our formula. So 115,762, that's coming from the formula over there, plus 36%, so I can go 36 over 100, of means times, and they want the taxable income amount above 488,700. So we're going to go 502,185,6 and take away the 488,700. Okay, then we can calculate from there, and we're going to go and just keep counting down. 115,762 plus 36 over 100 times by 13, 485,60. Next step is the percentage, the 115,762 plus, and 36% of that is 4,854,82. If we keep going from there and I add those together, we get to 120,616,82. Now the important thing here is we know this is not the tax. We still need to take away her rebate. She's under 65, so we're going to go 120,616,82 minus the 16,425, and that's the primary rebate. When you do that, her total tax for the year is 104,191,82. And then we need to see, is this amount, is this amount going to be more or less than a quarter of her salary? Because that's what she was claiming. So to do that, we're going to say, okay, well look, her taxable income that they told us was the 502,185,60. What is a quarter of this? So you could either say 1/4 times, or you could divide by 4, and it'll give you 125,546,40. And she was saying she pays more than a quarter, so meaning she was saying she pays more than this amount. But if we compare it, we can actually see her taxes less. It's only 104 as opposed to 125. So we need to give our conclusion, therefore invalid statement. Right. The other way you could have done this slightly differently is, instead of doing this 1/4, finding out what a quarter of her taxable income actually is you could have said what percentage of her salary is 104,000. And then seen it would have been 20%, which is not quite a quarter. But this, I think, is the more straightforward way of doing that, by just seeing what is a quarter of the taxable income, what is the tax, and then you can make your conclusion. Right, question 5.2, we've got here about Mrs. Neko, who is looking to relocate to New Zealand, and they give us the exchange rates to the pound and to the New Zealand dollar. And the first question we are asked is to determine the exchange rate of New Zealand dollar in terms of the South African rands on the 23rd of February. Okay, so the 23rd of February is kind of irrelevant because they've only given us exchange rates for the 23rd of February. But the important thing is they want to know New Zealand dollar in terms of rands. So in other words, how many rands for $1? So let's see what we already know. We already know that for 1 rand, according to the table, we can get 0,088205 New Zealand dollars. They're basically wanting the opposite. So this is quite a straightforward thing to do. All we're going to do is firstly write out our ratios. So we're told 0,0882 205, and we're told for 1 rand, rands, but they want a 1 here, so we want to know if it was $1, how many rands would it be? And you can do this a few different ways. The easiest way is to use a ratio and to just go 1 divided by 0,088205, and that will give you a pretty straightforward answer of 11 rand and 337. Right, so all I'm doing is I'm saying 1 divided by 0,088205. Right, the next question. Calculate the total cost of the visas to the nearest 100 rand that Mrs. Nickel and her husband must pay should they decide to relocate. So what do we know about the visas? Well, at the paragraph over here, they tell us that she needs a skilled visa, which is going to be 4,880, and her husband needs an entrepreneurship resident visa, which is 6,860. The capital investment amount isn't relevant to the visa, so we're only worried about those two amounts. Right, so first thing we need to do is find out how much are those visas going to be altogether. Well, it's going to be 4,880 for Mrs. Nickel and 6,860 for Mr. Nickel, which gives us the New Zealand dollars of 11,740. Okay. Now they do want this in rands, so we're going to use our exchange rates. We can use our exchange rate from our previous question, or we can use the exchange rate that we're given already over there. And all we need to do is say 11,740 divided by 0,088205, and that gives me 133,099,03, and they want it to the nearest 100 rand, which would therefore be 133,100. Where's your final answer? All right. The next question, 5.2.3, tells us that Mr. Nseko's brother offers to lend him the capital amount at an interest of 8.75% compounded annually over 2 years. Calculate how many New Zealand dollars he will have to repay his brother after 2 years. Right, so in this case, we can see that firstly we don't need to do any conversions because we are told that he needs 500,000 New Zealand dollars over there. And we're going to stick in the dollars because that's what they want our answer to be. Now, the other thing that we know is they're talking about compound interest. So compound interest, remember, adds interest onto interest. So you have to do this each year at a time, since they tell us it's being compounded annually, which tells us that we're going to have to first do year number 1 and then add on to year number 1 interest for year number 2. So you don't use formulas for this in Mathslit. We never use formulas. We are going to do it each year separately. So we're going to start with year number 1. And we're going to say, okay, you started out with 500,000. We need to add to that 8.75% of 500,000. Okay, that gives us 543,750. Then year number 2, and this is where simple differs from compound. We're going to start with our 543,750, and we're going to add 8.75% of 543,750. So that's the key thing to be noticing in this, is that the amount that we are doing our percentage on is actually the answer to year 1. And if you do that, we're going to get to our New Zealand dollars. I'm going to put in my units because it's my final answer. 591328,13. And that's your final answer there. Right, 5.1. This is all about the life science teacher who's doing research on bees. And he focuses mainly on the 3 kinds of honeybees, the worker bee, the queen bee, and the drone bee. And he's built scale models. So, first question we have here is the queen bee is approximately 2 centimeters in length, and the length of the teacher's model is 23 inches. So they want us to show that the model that he built is 29 times bigger than the actual bee. They also give us a conversion rate of half an inch is 12.7 millimeters. Okay, so let's think about what we need to do. Well, the first thing we need to do is move everything into the same units, because working in 2 different units is complicated, and we always want to work in the same units. So I've got 2 centimeters in length over here and 23 inches over here. It is entirely optional which sort of direction you want to move into. I think I'm going to rather move everything into millimeters. So just because we're more familiar working with units that are in the metric system. So I'm going to say if half an inch is 12.7, just label it. Then if I have 23 inches, how many millimeters will that be? And you can use a normal ratio method for this. I normally say we're going to divide by what's above it, so 23 divided by half, and then multiply across. So 23 divided by half times by 12.7. You could do it other ways if you think of a ratio differently. And ultimately you should get to 584.2 millimeters. Okay. Now, the other issue we have currently is that the queen bee is approximately 2 centimeters, which is not in millimeters. So we can just change this into centimeters. You could also change 22 centimeters into 20 millimeters. But I think I prefer working in centimeters. So I'm going to say, well, that's going to be 58.42 centimeters. Now, the next question was, is it 29 times larger? Because they're saying show that it is 29 times larger. So, to do that, we can say, well, how many times larger is it? So you could say, well, 58.42 divided by 2. Is that going to give me 29? Because if it does, then it's 29 times larger. And if you do that, you actually get 29.2, which is approximately 29 times larger. The other way we could have done this, as an alternative option here, would have been to go 2 times 29, which will give us 58 centimeters, and 58, and we had 58.42, so we could therefore say it is approximately 29 times larger. Okay. The next question says, write down the ratio scale for the enlargement. So whenever they're asking us to write down the ratio scale for the enlargement, I'm now looking at B over here, they're saying we want to start with setting up our ratio first. And our ratio is always the image, or in this case the model, versus the actual. So I'm going to take my information from my previous question. I can just move some of this out of the way. Let's just see. But the important thing that I need from this question is that I know what the model was in centimeters, because I know the actual in centimeters. There we go. Okay. So I'm starting with, what is the model size? We always start with the model, the image, the map, whatever the non-real item is first in our ratio. And then we create that as a ratio to what is the actual. And the actual, we know they tell us the actual queen bee is 2 centimeters. Now we need to change this into a ratio, and a ratio is normally we need to have a 1. Now it doesn't make sense for me to make the 58 into a 1. It makes sense for me to make the 2 into a 1 by halving it, and that we know gives us 29,2, technically 21 centimeters and centimeters. Okay, but there's a couple of issues with leaving it in this space. The first is in a ratio scale we do not have centimeters, we do not have units at all, so those need to fall away. And the second issue is we don't really want decimals, so in my final answer I'm just going to round that to 1. 29 is to 1. Okay. Whenever you have an enlargement, your scale is always going to have the larger value on the left. So in this case, the model was made larger than the real. Normally, when we're dealing with maps, it's the opposite way around. When we deal with maps, because we're taking a larger thing, which is like a road or a city, and we're making it smaller, that's why then our right-hand side of our ratio is normally the larger number. Okay. Then we had question 5.1.2. The honeybee flies at an average of 24 kilometers per hour and has a wing beat of 200 times per second, which causes the distinctive buzz. Show by means of calculation that the bee's wings will beat 300,000 times if it flew 10 kilometers. Okay, make some space here. So let's see what we know about this. We know that it beats 200 times per second. So 200 times per second, that's the first thing that we know. We also know it flies approximately 24 kilometers per hour. And they're asking us, what if it flew 300,000 times, sorry, if the wings beat 300,000 times for 10 kilometers. So in theory, my thinking here would be that firstly, I need to know how many times or how long does it take us to fly 10 kilometers. Because if I know how long it takes us, I can then work out how many beats it will make, how many beats the wings will make. So I don't need 24 kilometers for an hour, and I'm going to write this in a ratio. This is kilometers. This is for 1 hour. I need to know what if it was only 10 kilometers. How long would that be? So I'm going to use my divide up, multiply across. I'm going to go 10 divided by 24 times by 1. And if I do that, I get to a fraction of 5 over 12. Now it does give me a decimal. I'm going to leave it as a fraction because I don't want to round off my numbers just yet. You can say 0,416 recurring. It's the same thing. But for purposes here, this is in hours. But we have a problem because we know beats per second, right? Because that's what they gave us here, beats per second. So I need to convert this from hours into seconds. How do we do that? Well, 5/12 of an hour times by 60 will give me minutes. If I times that by 60, I get to 25 minutes. And then if I go 25 minutes times by 60, it gives me 1,500 seconds. Okay, great. Now I know how many seconds, and I know it was 200 beats per second. So if it was 200 beats per second, I need to times 200 by 1,500 seconds. And if I do that, I get 300,000 beats for 10 kilometers. Okay. And that's your final answer. The important thing here is because of the wording of the question. Notice the wording says show by means of calculation. It will beat this many. So if you calculate it and your answer doesn't get you to 300,000 times, then you need to go and reevaluate, because they're not saying prove it, they're not saying verify it, they're saying just show how you can get that answer. So the answer inherently is correct. You just have to find how to get there. Alright, our last set of questions was 5.2 with the landscaping gurus showing a top view of the botanical garden in the shape of a trapezium. They also tell us there is a circular tank with a diameter of 1,5 meters in the garden. We can see it there in the middle. So first thing they want is just to calculate the perimeter of the botanical garden. Perimeter is pretty straightforward. You're just going to basically add your way around the shape. So we're going to go 12. I always say, like, mark off the side as you go so that you don't miss it. Plus 5,5. There. Plus 6. Cross. Plus another 5,5. Okay. That's all you had to do. And when you add those together, you should get to 29 meters. Okay. Second question says determine the area taken up by the vegetable garden excluding the water tank, and they give us 3 formulae there. Area of the triangle, area of a rectangle, and area of a circle. Okay. So basically we need to cut the shape, this trapezium, into the shapes that we've been given. Now it's rather nice because they have actually included these vertical lines, these 4-meter lines over there, which makes it pretty easy for us to cut the shape into shapes that we know. So the first part that we're going to do, I think, is going to be the rectangle in the middle, because that's the easiest. If I look at this rectangle over here, I can tell the side of it is 6 and the other side of it is 4. So rectangle, we're just going to go 6 times 4 is 24 meters squared. Then they're talking about area of the triangle. Now area of the triangle is a little more complex because we have 2 triangles. Here's a different number for the triangles. Okay, I have one here and one on the other side. Now presumably these triangles should be the same size because this is a trapezium that they've given us. So we can work with that. I'm already going to put into my formula here, I need to say 2 of them so that I don't forget that. Then we need to know base times perpendicular height. Well, let's look at what the base will be. The base, if I look, should be 3. Now there's a reason I'm saying 3 here and 3 here. And there's a reason I'm choosing this as the base. If this is the base, I then need to be able to know the perpendicular height. And the perpendicular height of a triangle is going from my base side, a different color here, from my base side here, directly up at a 90-degree angle to the opposite point. Okay? And I have that measurement. I know it's 4 because they tell me that. I'm not using the 5,5 because if I use the 5,5 as a base, I would need to know what is the height of the triangle going from my base over here to the height of that point over here. And I don't know that. So I don't want to use the 5,5. Technically, I could have used the 4 because it would be very similar. I would go, well, if this is my base here, the 4, I need to know then the perpendicular height, which is going there. And I can get that as well. So it's just important that you identify the correct sides. So for my purposes, I'm going to say the base is 3. Now, where did I get the 3 from? The 3 was from me going, well, if it's 12 the whole way across, I cut up my 12 here. I know this part is 6, which means this part and this part together must also be 6 to get to 12 in total. So half of 6 is 3. So if this is a 3 and this is a 3, whoops. Then I get 3 and 3 is 6 and 6 and 6 is 12. Okay. So I'm going, my base is 3. So I need to go half times base of 3 times the height of 4. Okay, and if I do that, I get 12 as my final answer. You'll get 6 for one triangle, and 6 times 2 is 12 for 2 triangles, meters squared. Okay. Then the last thing that I need to do is I need to remove that water tank, because the water tank is the thing where they don't want us to include. So the water tank, I'll try a different color over here, is here in the middle. It's the circle in the middle. And they tell us area of the circle is pi times radius squared. So pi we know is 3,142, and you always show that. And then they want us to times it by the radius squared, but the radius is not 1,5, right? Because remember, radius is from the middle to the edge. 1,5 is going all the way across, which is our diameter. So our radius will be half of that, 0,75 squared. Okay. And then we can just pop that into our calculator to get to our answer. And it'll give us 1,6737 meters squared. Okay, so that is now the circle. So to find out the area of the vegetable garden excluding the water tank, we're going to say, well, we've got a 12, we've got a 24, it's a rectangle, and we want to exclude the 1,767,375, which is the tank, so I'm subtracting that. And that will give us a final answer of 34,23. I'm rounding to 2 decimal places because it's a measurement, meters squared. Final answer. Alright, the last question we've got here is define the meaning of the scale of 1 is to 15. So this is fairly straightforward. We're just going to say 1 unit on the diagram. Could have also said image is equal to 15 units in real life. That's all that it is. The important thing here I want you to notice is that I'm using the word unit because we don't know what the unit is. This could be a scale for a map where maybe centimeters is appropriate. It could be a scale for a model where maybe like millimeters would be appropriate. We don't know what unit would be the most appropriate because there isn't context to give us that. So when we're defining the meaning of a scale in general, we just use the word unit. And then it can be swapped out with inches, millimeters, centimeters, whatever you need for that. Okay, and that is the end of week 1's activities.